This is another paper that looks at adaptations that have been implemented across the globe to compound risks. Compound risks obviously are when multiple risks come together and often amplify each other's impacts. So flood followed by uh, I don't know, agricultural impacts, and then you have, let's say, a pest attack that amplifies the flood impact on the crops and so on and so forth. So let's read the highlights first. Compound climate impacts are particularly hard to adapt to. So you can plan for floods, droughts, sea level rise, etc. But how to deal with them when they combine with each other? Sea level rise comes with a cyclone, increased storm surge, and then there are increased risks of landslides because you have done land use change on building on slopes that's not very safe, and so on and so forth. Compound vulnerabilities and exposures constrain adaptation capabilities. So people may be vulnerable, able to manage vulnerability in one direction, but if multiple hazards come together to create a compound risk, then their exposure will be very different, and their vulnerability will be limiting their adaptation capabilities. Inappropriate responses to climate change can lead to maladaptation. So this is very tricky because it's the risks of the future that you ideally want to plan for. But as we have discussed before, maybe all the potential risks are already here for countries like, let's say, India or China, which have gotten hammered by various events this year, El Nino, global warming, extremes, floods, etc. So maladaptation is always an issue to worry about when you have not enough good information on climate risks and their evolution, and you create some hard and soft adaptations that make it a maladaptation over time. Compound impacts can have cascading effects on response options. Okay, so what do we mean by that? Let's read summary and then look at a few more details. This article provides a stocktake of adaptation literature between 2013 and 2019 to better understand how adaptation responses affect risk under the particularly challenging conditions of compound climate events. These have a definition, but intuitively what you can think of is basically what it is. Across 39 countries, 45 response types of compound hazards display anticipatory, reactive, and maladaptive characteristics. So maladaptive here are 41%, the highest of the three considered here, as well as hard and soft limits to adaptation. So as you remember from the previous podcast, hard limits are where you have hit a wall and there is just no option available for adaptation, whereas soft limits are those that can be overcome with resources, with planning, with technology and governance, and so on and so forth. Low income food security and access to additional resource and finances are the most prominent of the 23 vulnerabilities observed to negatively affect responses. Risk for food security, health, livelihoods, and economic outputs are commonly associated risks driving responses. Narrow geographical and sectoral foci of the literature highlight important conceptual, sectoral, and geographic areas for future research to better understand the way responses shape risk. So now in the new IPCC AR6, in fact, risk is defined as a multiplication of hazard, vulnerability, exposure, and response, because response actually shape the risk as well. Responses shape the risks as well. When responses are integrated within climate risk assessment and management, there is greater potential to advance the urgency of the response and safeguards for the most vulnerable, which is often the most important goal, to protect the poor and the most vulnerable. So here we are looking at a phase space of no hazards and number of articles, where they come from, and India here is a strong blue color in this corner in terms of high number of hazards and a reasonable number of articles. Okay, so you can see how they are spread out. Of course, rich countries are there, and high hazard number countries. So here this purplish, whatever this color is in the corner of low number of articles and low number of hazards. So Africa is mostly without much research. Of course, Sahara is all not inhabited so much. So Russia is very low in this game. China is also in this corner with number of articles being low and number of hazards being low for whatever reason. Okay, so what are the hazards? Drought, extreme heat, heat wave, mean precipitation decrease, flood, pluvial and coastal, landslide, extreme precipitation, coastal erosion, relative sea level rise, increased precipitation variability. So there are extremes and then there are increased variability without having extremes. So just dry, wet kind of situations. Increased salinity, rapid snow melt and tropical cyclones. So here you have global distribution of literature. I won't go into the details, but you can see that the highest number of studies are focused on drought, and most of them come from Asia, and of course India is in there as well. The vulnerabilities affecting the responses to compound climate events. This is important to understand what are the kind of indicators that are used. So here there is a categorization by primary vulnerability, secondary, third, fourth and fifth vulnerability. So basically, you know, where your primary vulnerability comes from. So here we have various dimensions of vulnerability to make better sense of that. So inadequate shelter, elderly, so age groups which are more vulnerable, elderly are. Informal dwellings, basically like slums in urban areas. Gender-based violence, women-headed households are more vulnerable here in terms of fourth and third vulnerabilities. Mobility, informal sector, so that's employment that's not permanent, not guaranteed payments, can be all kinds of issues. Limited access to energy, family size, limited education, migrant status, indigenous community, chronic health challenges, low climate change literacy, gender, social capital, lack of access to land, dwelling in high-risk areas, lack of access to climate services, limited access to finance, limited access to institutional resources, food insecurity, and low income or no income. So you can see primary vulnerability here is very high. This is frequency of references to each dimensions of vulnerability in the literature they have been surveying. Across all adaptation-related responses to compound climate events, analysis of articles identified the most important vulnerability affecting the response as primary vulnerability, followed by other dimensions of vulnerability affecting responses in terms of secondary, third, fourth, and fifth vulnerabilities. Compounding drivers of risk to food security as an example, highlighting the effect of multiple intersecting vulnerabilities. So you have hazards, vulnerability, responses, and exposure. This is the IPCC framework for defining risk. So we are focusing here on risk to food security. So from the hazards, of course, you have drought, extreme heat, increasing average temperatures, and vulnerabilities come from chronic food insecurity, lack of access to land, and low income. And you have from the responses side, harvesting wild fruits, rural to urban migrations, commercialization of garden produce, and exposures relate to length of exposure to drought, intensity of heat waves, spatial extent to drought. These also include things like infrastructure, population density, and so on and so forth. Okay, so let's look at some identified responses to compound climate impacts and events and their relationships to key risks. For the 10 most commonly identified key risks in the adaptation literature, all 45 classes of 175 adaptation-related responses are identified together with the compounding hazards to which they are responding. 17 hazards are shown by icons in the top left of each box and responses together with their article number count in the bottom right. Each set of 2 main compounding hazards is listed separately. For instance, For the risk of food security, conservation agriculture responses targeted two sets of compounding hazards: drought and flood pluvial. So you have drought going on, and then rainfall elsewhere causes pluvial floods, which would have reduced the soil water holding capacities, and basically runoff will be higher, and also erosion will be higher, and so on. Mean precipitation decrease and extreme heat, heat wave and heat island effect. So acronyms: indigenous knowledge and local knowledge here. Complicated looking charts, but just look at the various hazards: aridity, drought, rapid snow melt, extreme heat, heat wave, heat island effect, severe cold spell, fluvial and coastal and storm surge floods, increased precipitation. So in the vulnerabilities, increased precipitation variability, late onset of the rain like the monsoon, which completely screws up the crop calendar and the crop cycles. Mean precipitation decrease, mean precipitation increase, landslides, coastal erosion, wildfires, extreme precipitation, windstorm, snowstorm, relative sea level, tropical cyclone, increased salinity, and these can combine with each other, as we just saw. Okay. So food security, you have various options in terms of responses: conservation agriculture, increased irrigation, crop diversification, livelihood diversification, technological and innovation options, altering fishing practices, and so on. Under health, you have regulations, disaster risk management, institutional actors, building design, communal pooling resources, migration, climate smart agriculture, food forced displacement, water harvesting and storage, and so on. And similarly, you have in other sectors or other dimensions: loss of livelihood, infrastructure, decrease in economic outputs, water security, civil unrest, extreme poverty, loss of indigenous and local knowledge, and biodiversity. Okay, so number of papers are listed in each one. It's good that the literature covers so many dimensions and so many responses, so many sectors, so on. But what does it amount to? So effects and characteristics of responses to compound climate events. There are some anticipatory or reactive responses. So you are you are preparing yourself based on what is expected as anticipatory responses or reactive responses. Things set in and then you begin to respond, and hope that it's not too late. Effects of responses on vulnerability are seen here. Effects of responses on exposure seen here in C. Okay, and so on. So anticipatory or reactive I'm not a native English speaker, as you can see. Anticipatory and or reactive responses include mixed, so started as reactive but then done proactively in subsequent years. You learn your lessons and you learn to respond before things go bad. Proactive or anticipatory responses, 9%. Reactive response here. Similarly, here you have effect of responses on vulnerability. So avoided vulnerability, reduced vulnerability, increased, and no effect. Effect of response on exposure: no effect, increased, reduced, or avoided exposure. Effect of response on other responses: no effect, not reported, supported other response options like co-benefits and synergies between different responses. So responding to drought with conservation agriculture may also affect water and response to water sector or energy sector, for example. Reduced effectiveness of other responses in some cases, because each siloed work can take away the responses or diminish the ability to respond in other options. Okay. Cascading effects of the compound interactions identified. Cascading effects of the compound interactions identified. I don't know why I'm fumbling. Sorry, I'm hungry. Contagion nonlinear contagion or nonlinear cascade, compounding impact, and domino or linear cascade. Maladaptation related to compound or cascading effects not reported, yes, no. So you can see 41% of them report maladaptation, which is bad news, which means adaptation plans were not properly done, risks was not properly known, or could be many other reasons why maladaptations occurred. Okay, let's read the conclusion. The greatest risks from a changing climate may not come from individual climate impacts or risks, but from the interactions and interdependencies between cascading and compound climate impacts and socioeconomic and geopolitical vulnerabilities. In other words, the nexus between compound climate hazards, exposures, existing intersectional vulnerabilities, and multiple types of human responses. El Nino is playing out now, and India limited export of rice to protect itself for the eventuality that rice harvest may be low this year. So then Indonesia, which wants rice from India, will suffer because India is not exporting as much. So you can see how your vulnerabilities get amplified by climate factors and anticipatory response to climate factors, right? These interactions can be mapped via available tools and analytic methods such as the Circle tool for infrastructure and system interactions. References are given that you can look up because I'm not getting into details as to what the Circle tool is. Exploratory modeling analysis with exploratory modeling analysis with integrated models that capture interactions between sectors, pathways analysis, and predictive modeling through the use of artificial intelligence techniques. However, compounding risk increases complexity, and existing tools to support decision makers would need to be further tailored to systematically assess interactions of risk and responses across space and time to support the development of adaptation plans that properly account for compounding risks. This will not, however, rule out surprises, which points to the need for warning and response capability in the context of learned experience. So the things that were reactive responses that become anticipatory responses are learned experiences, for example. Analogs exist from which we can learn. Disruptions in global food supply chains arising from a combination of COVID-19 and the war in Ukraine are demonstrations of the types of risks we can expect from climate change and a reminder of the importance of compound and interacting risks. So war in Ukraine ended up hurting wheat exports, other grain exports, fertilizer availability, and of course perturbations to the energy markets, which cascaded into food, water, and other issues as well. So these are complicated, which also raises the question about how well the future projections are capturing such eventualities or range of interactions between socioeconomics, geopolitics, and compound climate risks. Okay. Nonetheless, you hope that the projections somehow are spanning the range of possibilities in terms of pathways for mitigation or global warming targets, but that still doesn't say how local and regional risks evolve through time in these scenarios, and how adaptation plans can really be made with such complicated scenarios coming out of nowhere. Okay.